Alright, so we spent the entire last period talking about different postulates that we can use in order to determine if triangles are congruent. All of those required that we be able to prove that some of the sides and or some of the angles were congruent, right? And if we had enough, we said we could prove that the two triangles were completely congruent. So, we're going to fill in these blanks that say, since congruent triangles have the same size, then their corresponding, remember corresponding just means the ones that are in the same spot, corresponding sides are congruent. And since congruent triangles have the same shape, we then know that their corresponding angles are congruent. Okay, so keeping that information in mind, they give us these two triangles here below. This one ABC, this one DEF. And we are going to talk about which of the pieces correspond with one another. So, angle A would correspond with what? Right. Okay, so in this blank, I'm going to say angle A corresponds with angle D. I would also say that angle B corresponds with which one? Alright, and then lastly, we could say that angle C corresponds with angle what? Alright, so if all of these angles correspond, then they should all be congruent if we're trying to say that these two are congruent. So I could make this statement that triangle ABC is congruent to triangle DEF, but we also would need all of the sides to be congruent as well, right? Particularly the ones that correspond. So, what side would correspond with AB? Right. So I would say that segment AB corresponds with segment DE. Alright? And which segment corresponds with BC? Good. And then lastly, with our third side, CA, which one corresponds? FE, good. Okay. So again, corresponding sides and angles are just the ones that are in the same spot. Okay, so they then give us this example that triangle BIG is congruent to triangle CAT. So even though they're not drawn out, we should be able to tell which pieces are congruent or corresponding because of their order. Okay? So angle G, what should be congruent to angle G in the other triangle? Angle T, because they're in the same spot. Alright, on number 2, what angle should be equal to angle A? Angle I. On number 3, what side or segment should be equal to BI? Very good. And what segment should be congruent to AT? Right. they list the order of the letters as triangle IGB, I would say that's congruent to ATC. Good. All right. Then lastly, triangle CTA is congruent to GI. So even if the picture's not drawn, as long as they listed the letters in the correct order, we know which pieces correspond anyway. All right, example 7 says we've got these two triangles, triangle DEF, that is congruent to triangle RST. Again, make sure that we list our vertices or our points in that same order for each figure. They then tell us that the measure of angle D is 100 degrees. So right here we got 100 degrees. And that angle F is 40 degrees. And they want us to list 4 angles that are all congruent. Okay, so is there anything that we already know should be congruent? Okay, so D and R match up, and F and T match up. Okay, is there any way we can find the missing ones? We know that their angle sum is 180, so we just subtract out the 140 that's already taken up. So what's that missing angle? Okay, and if angle E is 40, so is angle S, right? So do we have 4 angles that are all congruent? Yes. Yeah, we ended up with 4 that are all 40 degrees. So I'm going to list them all out. So we've got angle E is congruent to angle F. That one was also 40. Is congruent to what else? Angle T, which is congruent to angle S. So all 4 of those are all congruent. Okay. Okay. Here at the bottom it says in this previous section we have observed that when 2 triangles had so many congruent pieces, so when we had all of the pieces being congruent, so it says all 6 parts, right? So that would be the 3 sides and the 3 angles. Then they were all congruent. So in order to prove that 2 triangles are congruent, we don't have to know all of the sides or all of the angles, right? Our postulate said that if we knew 3 certain things, then we were able to tell that the entire triangle was congruent, right? So sometimes we just need 3 pairs of congruent corresponding parts to guarantee that your 2 triangles are congruent. Okay? So remember the ones that we covered so far were side, 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 and side, angle, side. And then we learned about angle, side, angle, and angle, angle, side. So we learned 4 so far. In this next section, we're going to strictly be talking about postulates and theorems, which are our reasons, right? The angle, side, 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 things like that, okay? So we are dealing with postulates and theorems. Okay? We also have learned some properties and things prior to Unit 4 that we could use as well if we want to, like substitution and alternate interior angles, right? We know certain things. All right, so flip it over onto the next page, and they remind us of all the postulates that we learned last time you were in here. We got our side, 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 angle, side, angle, and angle, angle, side. But if you guys remember, I told you there were 5 total on the last 2 sets of notes. We said that there were 5 postulates. Well, we've only learned 4. So this is the 5th one, HL. stands for hypotenuse and leg. So if you want to mark that so that you know what H and L stand for, you can write that down. The one across from the 90-degree angle. Okay. So in order for you to have a congruency by the HL postulate, you have to have a 90-degree angle specifically. So you got to have this 90-degree angle. You got to have that your hypotenuse is congruent, which is the side across from that angle, as well as the leg, which is just one of those straight sides on either side. Okay, so those are our 5 postulates that prove triangle congruency by just knowing 3 things. Okay. All right. We also, on those 2 sets of notes, talked about things that we know to be congruent that are not necessarily marked, right? On the very first set of notes, the first thing we said we know is congruent is a shared side, right? Because it stays the same whether I'm looking at the triangle it's connected to on the left or the triangle it's connected to on the right, the side stays the same, no matter what. So specifically in this figure over here, the side AC is the shared side, right? Okay. We had properties back when we were talking about proofs the very first time. We went over a long list of properties like substitution, transitive, addition, subtraction, right? All those. And we had one that said it doesn't matter where it is, what part I'm looking at. If I have some segment AC that I'm looking at in the top triangle, it's still equal to the same segment if I'm looking at the bottom portion. So that property was what we wrote down was the reflexive property. So if you want to go back and refer to your notes, I believe that was our 3.5 notes. But all this property says is that that segment doesn't change no matter which part of the figure I'm looking at. So in this specific figure over here, it says that those 2 segments, AC for the top and AC on the bottom, are still congruent because it's the exact same side. So in a proof, something that I might say, if I wanted to use this as a congruent side, is that AC is congruent to AC, and the reason that I would give would be this property, the reflexive property. Okay? All right, the next thing that we said that we were able to mark, even if it wasn't drawn, was our vertical angles, right? So specifically in this figure over here, our vertical angles would be right there. Okay, so I would be able to say that we know that these are congruent because we know that vertical angles are congruent. So I might name this bottom angle JBL. I could say that angle JBL is congruent to the same thing in the top. If I started with the J, then I would start the other one with the A. Right? JBL, ABC. So I can say that those 2 angles are congruent because you guys said that they're what kind of angles?
Vertical.
Right. So that would be our reason. Vertical angles, which we know are congruent. Okay. All right, and then back in our last unit, we talked about angle bisectors. We said that that angle bisector did what to our angle? split it in half, right? So when it splits it in half, we end up with two pieces that should be the same, right? So if you are given an angle bisector, then the angle is divided into, like you guys said, two equal parts, or two congruent parts or angles. So in this figure here, if they told you that that line segment EG bisected the angle, they would say something like EG bisects angle E, and that would be, and then beside it they would say given, right, if this was a proof. Okay? So you guys just said that that line segment, what that means is that it cuts this in half, which would make the angle right here equal to the angle right here. So if they told me that it was bisected or cut in half, in my proof, I could follow that up by saying that this angle is equal to this angle, right? So that first one that I traced out was is congruent to what did you say? Okay. And the only reason that we know that to be true is because of the definition of what an angle bisector is, right? That just means cuts in half. So our reason behind it would be definition of angle bisector. And feel free to use any of these abbreviations in your proof as well if you would like. Okay? Alright, so next one, segment bisector. We kind of talked about these all the way back in Unit 1, when we talked about how you come up with that line that would cut a segment in half. But if we already know that an angle bisector is something that cuts an angle in half, we obviously also know that a segment bisector is just something that cuts a segment in half. So, if you are given a segment bisector, then you know that that segment has been divided into two congruent segments. So, for example, if you were given some figure like this, and they wrote as a given statement that B, which is this point right there, if they said that point B bisects that whole line segment, which is, what is those letters, J, A, then I would know that the first piece of that line should be equal to the other piece of the line, right? So if I split it in half, B would be the midway point, so I could say that segment JB is congruent to segment BA or AB, whichever way you want to list your endpoints. And we only know that that's true because we know the definition of what a segment bisector is. So the reason behind it would be definition of segment bisector. Alright, and then the last one is those alternate interior angles. So what did we have to have marked for us to know if we have alternate interior angles? Right, gotta have parallel lines being cut by some transversal, right? Some line that's going through them. So you gotta have parallel lines and a transversal. If you've got your parallel lines and a transversal, then you know you can have those alternate interior angles, which we know to be congruent. So on this figure over here, I don't think they gave you any points. Maybe we just name this figure A, B, C, D. Well, those arrows are what tell us that line segments are parallel. So they marked this end and this end to be parallel. So we were given that segment AB is parallel to segment BC or CD. And because we have that as well as that transversal BD cutting through it, then we can have alternate interior angles. So we could have a pair here, or you could draw them on the other sides, right? Just as long as they're on alternate sides. Okay, so I would maybe name that first one angle ABD, and I could say it's congruent to angle CDB. Or if you drew them in the opposite corners, you would obviously switch that up, right? Okay, and we only know that that's true because we had parallel lines. So we were able to have alternate interior angles, and we know that alternate interior angles are congruent. So whenever you're writing proofs for triangle congruencies, these are pretty much going to be the ones you use every time. So, in my opinion, these are a little more simple than the ones we were doing over angle pairs because you basically use these every time. Okay? So, flip it over onto the next page. And they want us to fill in if we think the triangles are congruent. If we say yes, list all the possible ways they could be congruent. So if they're congruent by more than one type, write them all down. So remember we got side, 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 angle, 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 side, and we just added the HL, hypotenuse leg. Okay. So on number 8, what do we have already marked for us?
Side.
Well, they marked 2 of the sides, right? But we can assume we have 3 sides because we got a shared side, right? No angles though, so we do know it's congruent because like he said, we know we got that shared side by side, side, side. Okay, on number 9, what's marked for us? Parallel lines. Anything marked as congruent though? Right, we just have 2 line segments marked as congruent, okay? So if we've got parallel lines, what are we probably going to go ahead and mark? Perfect. So I could have one here. I could also have them on the other side. Okay, so alternate interior angles. That gave us 2 sets of angle pairs, and we already had a side marked as congruent. So are these 2 congruent? By very good. Okay. You also could have added in the shared side, right? If you added in the shared side, you could also say that these are congruent by side, angle, side, or angle, side, angle, right? Either one. But that would require you to draw in an extra side. You could also list this. All right, on number 10, anything marked as congruent? No, but what can we add in? Shared side, what else? Alternate interior angles here and here, as well as here and here. Okay, so are these congruent? Yes, by, what is it? Angle, side, angle, very good. Okay. All right, number 11. What could we draw in that's not already drawn for us? Shared side, okay. All right, so we've already got 2 pairs of angles that are congruent. Now we've got 2 sets of sides that are congruent. So we got a lot of options here, right? So what are all the ways that we could say that this figure is congruent? Hypotenuse leg, good. What else? Side angle side. one that we can't say for this one is side, 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 right? We don't know anything about those. Okay, number 12. What can we draw in? Vertical angles. Okay, so if we've got vertical angles, we got these angle pairs marked and those sides, angle side, good. Alright, and last one. What did they give us here? Okay, the only one that we have for two sides in an angle is SAS, right? And that means the A has to be the included angle. And is the angle that they marked the included angle? No. So do we have enough information to prove congruency? So we have to put no or not possible on this. Just based on the information that was there. And because they don't actually touch, we can't draw it. Okay, so in case you were worried about not getting to the proofs, we got plenty of those too. Alright, so on number 15. They have that we are given that the segment PR, this line right here, bisects angle P, this angle, and angle R. What does that mean? Cuts it in half, right? Okay, so whenever we do a proof, the first thing we always write down is the given, right? So I'm going to write down what they wrote, that PR bisects angle P and angle R. And the reason I'm able to write that down is because it was given. Alright, then I should always use whatever they just said to lead me into what I'm going to say next. Well, you guys just were saying that a bisector, an angle bisector, means it cuts the angles in half, right? So what would that mean about angles 1 and 2? Congruent. So I should be able to say that angle 1 is congruent to angle 2. And why are we able to say that? Perfect. Okay, and if I can say angles 1 and 2 are congruent, I should also be able to say that about 3 and 4 as well. Angle 3 is congruent to angle 4. Sorry, I should have marked this different. Again, because of perfect. Okay. All right. So we're supposed to end up proving that these two triangles are congruent, right? And that's always what we put as our final statement. So we've only got one spot left to really fill in on our own. Okay, if I'm going to prove that two triangles are congruent, we got to have three things, right? Okay, so we already came up with two. We got two sets of angles, shared side. All right, we got a shared side here. So we do know that the segment PR should be congruent to the segment PR. And what property did we say that was? Reflexive property. Very good. Okay, so now we got two sets of angles and a side. So we do have three things, right? So I can go ahead and make the statement that they wanted us to make, that triangle PQR is congruent to triangle PSR. And what postulate is it? What type are these congruent by? Perfect. So angle, side, angle, postulate. Alright, let's look at another one. On number 16, what should I put as my first statement? The given. So we got WO is congruent to ZO, and we have that XO is congruent to YO. And what's the reason for that? Okay, so I'm going to come over on the figure and mark what we just wrote down. WO, which is this line here, is congruent to ZO, this line here. And they said that XO, which would be this line segment, is congruent to YO, which would be this line segment. Okay? All right, so they actually already gave us 2 out of our needed total of 3 things. Right? So is there anything that we could assume or draw in ourselves? Vertical angles. Okay, so I would say that angle WOX is congruent to angle ZOY. Because we know that they are right. Which we know are congruent. Okay, so they gave us 2 sets of congruent sides. We marked the congruent angles. Is that enough information to prove these triangles are congruent? Yes. So I can say that triangle WXO is congruent to triangle ZYO because of what postulate? We got our side angle side. All right. One more. Okay. We flip it over on the back, and what am I going to write down for my first statement? The given. So we're going to have that YZ is parallel to AB, and that YZ and AB are congruent. Okay, and we're able to write that down because it was right. Okay, and they already marked all that information down for us over here on the figure. Okay, so if we have that these sides are congruent, is there anything that's not marked that we can add in? Alternate interior, and I heard somebody else say something, and shared side. We can mark both of them, right? So we got our shared side as well as some alternate interior angles. Okay. So the shared side, we could say that that segment YA is congruent to segment YA because it's the shared side, or what property is that? Good. Okay. And then we also said that we had some alternate interior angles. So angle, that would be ZYA is congruent to BAY. Is that right? Yeah. Because those are what kind of angles? Right, so we got parallel lines that implied alternate interior angles, which we know are congruent. Okay, so we got 2 sets of lines, a set of angles. We could say that these 2 triangles are congruent by somebody said it over here. Side angle side. Good. Oops, congruent to triangle BYA by side angle side.